Oh, hey guys, just listening to my synthetic music. Why, you ask? Because today we're going to be doing synthetic division. Welcome to Chapter 3, 3.2 Notes Day 1, Synthetic Division. All right, we're going to do this nice and quick, guys. Don't want to take up too much of your time, but here's the deal. In the past, we've had to do long division. You probably remember this, and you might be kind of groaning. But as a reminder, before we do long division, this says find f of 4. So this is our warm-up. We're going to plug in 4 when we find f of 4. Minus 2 parentheses 4 quantity squared minus 150. Excuse me, plug and chug that into the calc, and we get 10. So this is a warm-up right there of plugging in and evaluating. Second warm-up problem is, of course, long division. Use long division to calculate f of x divided by g of x. All right, f of x is that longer polynomial, which is 3x cubed minus 2x squared minus 150 over x minus 4. So the x minus 4 comes outside. Inside, we're going to do 3x to the third. There is an x squared term minus 2x squared, but there is no x term. So we don't want to forget the plus 0x, okay? And then minus 150. All right, so if we can recall what we did back in the day, 3x cubed over x is 3x squared. We would then multiply. X times 3x squared is 3x to the third. We would distribute, so then we would get a minus 12x squared. Then we would draw the line, change all the signs, and we get a 10x squared. Drop down that 0x, and once again, repeat the process. So here we would get a plus 10x, multiply through, x times 10x is 10x squared. Now, negative 4 times 10x is negative 40x. Draw the line, change all the signs again, and we get 40x. Drop down that minus 150, and complete the process. So 40x over x is just 40. And negative 4 times 40 would be negative 160. Draw the line, change the signs, and we're left over with a remainder of 10. Final answer, 3x squared plus 10x plus 40 plus our remainder, which we would put over the x minus 4. Hopefully that brings back some wonderful memories, but I'm about to make your life a whole lot easier. I'm also about to make you pretty mad at me because we could have been doing something easier the whole time. Introducing synthetic division. Synthetic division is a method used to divide a polynomial by a first-degree binomial. So there's a couple rules here. We can't just do synthetic division with any old binomial. It's got to be a first degree. So if this was x squared, we'd have to revert back to long division. Okay, now look, guys. There is a list of steps right here. They seem daunting, okay? But it's not that bad. I'm just going to go through the examples, and then you can always go back and read the notes and try to make sense of these steps. I'm not going to read through these steps right now, okay? I'm just going to do the problems. So let's start with the exact same problem we just did, and let's use synthetic division to actually do the problem. So my first step, guys, is to list out just the coefficients of every term of the polynomial that we are going to divide. So the first coefficient is 3, then negative 2. So I'm just going to leave a little space and write a negative 2. Don't forget that there is that 0x, so we do have to put in a 0 for the x term. And then finally, we got the minus 150, so negative 150. All I did was list the coefficients. Now this is the strange part. I'm going to make what I like to call a window over here. And this is, in the window, we're going to put what we're dividing by. Now here's the deal. This is called a factor. We need to put in what's called a 0. Well, maybe not a 0, but we need to put in the number. And to find the number, not the factor, you are going to set this equal to 0 and solve. So essentially, you're going to change the sign of whatever this is, okay? And that's what you put in the window. So you set that equal to 0, that factor equal to 0, and you solve to get the number that goes in the window. So you change the sign. That's the shortcut. All right, now we're going to start what's called synthetic division. The steps are as follows. You take the very first term and you drop it down. It stays there. Drop it low. All right, so we drop that first term. We then will take this first term and multiply it by the window number. 3 times 4 is 12. And I put that 12 underneath the next number, and now I'm going to add together these two numbers. So -2 plus 12 is 10. And now I'm going to repeat the process. 10 times 4 is 40. Put her in right there. Add those together. 0 and 40 is 40. 40 times 4, so now I'm multiplying again, is 160. And 160 plus -150 is 10. I'm done. The last number that you get, always, 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 is your remainder. The second to last is always going to be the constant. And then you just work your way backwards. This is going to be the x term, and this is going to be the x squared term. If there was something else, it would be x cubed. If there was something before that, it would be x to the 4th. You just work your way backwards. So then you write out your final answer, which is 3x squared plus 10x plus your constant, which is 40, plus your remainder, which you still put over the factor from the original problem. All right, that's it, guys. That's synthetic division. Hey, by the way, samesies. You might be a little mad that we've had to do long division up until this point, but sorry, not sorry. Let's do one more. Okay, list the coefficients. 1. There is no x to the 4th. Put in a 0. X to the 3rd is -4. Don't forget that negative. There is no x squared. Put in a 0. There is an x. The coefficient is 1. There is no constant. Make sure you put in a 0 for the constant, too. Now, you might be thinking, all right, now what goes in the window? Change the sign. So x is -3. That's what we put in the window. And now we do our synthetic division. I'm going to go faster this time. You guys ready? I think I heard someone say yes. Drop down the 1. 1 times -3, -3. 0 plus -3, -3. -3 times -3, 9. 9 and -4 is 5. Now we multiply. 5 times -3, -15. Plus 0 is -15. Times -3 is +45. Plus 1 is 46. 46 times -3 is -138. Plus 0 is -138. -138 is my remainder. Constant, x, x squared, x cubed, x to the 4th. Final answer, x to the 4th, minus 3x cubed, plus 5x squared, minus 15x, plus 46, plus -138 over x plus 3. Wow. Record timing on a division problem. Now here's something that's interesting. Let's find f of -3. Oh man, let's see. We're going to plug in -3 to the 5th power minus 4 parentheses -3 cubed plus -3. Plug that into your calc. If you do it correctly, you get -138. The observation we want you guys to make here is that this is equal to the remainder. This is a fact of life. Whenever you get the remainder is f of whatever that window number is, okay? That's actually called the remainder theorem, all right? Let's see, we can actually do this with fractions, so I'm going to show you that. And then we'll just quickly talk about the remainder theorem and call it a day. Okay, so the window number is going to be positive 1/2. We get a 2, we get a -1, 10, and 5. All right, all I did there, list the coefficients. There was no missing terms, so no zeros are needed. Now we do the synthetic division. Drop down the 2. Half of 2 is 1. Add those together, 0. Half of 0 is still 0. 10. Half of 10 is 5. Add those together, and we get 10. That's my remainder. Constant x squared. So even though there's a 0, that counts as your x term. The way you would actually write your answer, though, does not include the 0. You would just say, oh, 0x is just 0. You can leave that out. Plus 10 over x minus 1/2. Gorgeous. That's the answer. And now just to prove our remainder theorem point, let's find f of 1/2. So that's 2 parentheses, 1/2 cubed minus 1/2 squared plus 10 times 1/2 plus 5. Now, I don't know about you guys, but this took me like, 20 seconds? Doing this, even if I get to use my calculator, which, by the way, you won't get to use your calculator, is going to take longer. So this is a new way to do f of whatever the number is. It's just plugging into synthetic division and chugging along. Whereas this, you'd have to actually cube the fraction, multiply it out, and guess what my answer is going to be? It's going to be 10. Okay, so did you notice any connection? Of course, it's the remainder theorem. The f of the number is the remainder when you do synthetic division with said number. Okay, so last example of these notes is example 4, and then I'll stop talking. Now, this says, and this is similar to some test questions or quiz questions, find f of k by doing synthetic division. So to find f of k here is -1, so this just means we want to find f of -1. Now be careful here, you guys. Notice this. In these problems, they gave me the factor, and that's when I had to change the sign, okay? But when we found f of the number, it was the opposite sign of what they gave me. Here, they're not giving me the factor, they're giving me the k value, so I will not change the sign. So when you're given a factor, and factor is technically not even the word I should be using, but if you're given a binomial, okay, that is when you change the sign. Whereas if you're given a k value, you don't change the sign. So what we're going to do is just put -1 in the window. My coefficients are 1, -4, 2, and 1. Do your synthetic division. Drop down the 1. 1 times -1 is -1. Add, we get -5 times -1 is +5. 7 times -1 is -7, plus 1 is -6, and that is the remainder, which means f of -1 is -6. And that's it, guys. All right, hopefully that made sense. Just to summarize, we learned synthetic division. Go back in the video and listen to my steps, or reread these steps if it's at all confusing. We also learned that the remainder is also f of whatever the window number is. That's called the remainder theorem. We also learned that if I'm given a binomial, again, I shouldn't have said factor, but binomial, if I'm given a binomial, that's when I change the sign, whereas if I'm given a k value, I don't change the sign. You can try this next problem on your own, and you can try the homework. Have a great day. We'll talk to you.